Hello everyone, welcome back. So we are going to study 2.4 quadratic graphs, and before we learn that, there is something we need to know. So for the quadratic graphs, it's always a curved shape, so we call it parabola, all right? And then the coefficient of x squared determines the overall shape of graph, which is a is going to determine the shape. If a is a positive number, then it's like this. So if a is negative number, then it's going to be like this. All right. So for the curve, that we need to know some critical points. So like this shape, this point is minimum value for the function, and like this shape, this one is going to be maximum point. And then the curve intercept the x-axis. We call it roots. Sometimes there is no roots for the quadratic equation, like this or like this. Okay. And also this point we call turning point. Okay. So let's move on. So we could have quadratic equation have by completing the square, and then it's going to become fx equals a times x plus p squared plus q, and then the turning point coordinate is going to be negative p q. Okay, all right, so let's move on to look at example 11. So you need to sketch the graph of y equals x squared minus 5x plus 4 and find the coordinates of its turning point. So look at this graph, we will know a greater than 0. So the shape is going to be like this. And then it's going to have a minimum value. So what is the minimum value? We can take it, complete the square. Then we should have x minus 5 over 2 square, and then minus 4 to 5 plus 4, and then equals x minus y over 2 square minus 9 over 4. So the turning point coordinates is going to be 1 over 2 and then negative 9 over 4. All right. And then to find the two roots, we can factorize it. So we could take it x minus 1 times x minus 4 equals 0. So two roots should be x equals 1, another is x equals 4. All right. So we have the minimum, one is about 2.5, another is 2 point around here, and two roots, one is 1, another is 4. Okay, so the intersection of the curve with y-axis, so we can take x equals 0, we can get the intersection point on the y-axis, y equals 4. So it intercepts y-axis at y equals 4. So that's the whole function is going to be like this. Okay, it's symmetrical. All right, let's look at the final answer. Right, so I drew it correctly. So this is the final curve. It's just a sketch, not that precise. Okay, all right, so let's move to example 12. So sketch the graph y equals 4x minus 2x squared minus 3, and then find out the coordinates of its turning point and then write down the equation of its line of symmetry. All right. Okay. So the equation y equals 4x minus 2x squared. So we need to let x as descending order, so that we have negative 2 squared plus 4x minus 3. Since a less than 0, the shape is going to be like this. Okay, all right, so if we have x equals 0, y equals -3, which means it's gonna, the intersection with y-axis is 0, -3. And then let's try to find out the roots of the function. So could we factorize? Let's look at the function. So -2 and -3. So you can take 1, -3 and a 1, 3. Is that possible? Not possible, right? So the only way we could find the roots, use the formula. So 2 times -2, 4 plus 4 times 2 times 3. So there's no need to change the sign, okay? So the answer should be -4, -4, positive plus, then it's -8, which means there's no real solution because you will never find a number its square equals a negative number, because a number's square is always greater than or equal to 0. So let's look at it. So what is the turning point? So we're going to 2x plus 4x minus 3, and then we can take -2 out, x squared, then minus 2x minus 3, and then -2x minus 1 and minus 1 minus 3, and then final answer is going to be -1 squared and then minus 1. So the turning point coordinate is going to be 1, -1. So 1, -1, okay, and then the whole graph is going to be like this. And then the coordinates of turning point we have already found, and we also need to find the equation of line of symmetry. So the line of symmetry is always at the turning point, so that this is the line of symmetry, which is x equals 1. This is the symmetry line. So we finished the example 12. All right, so let's move to the next. So for the exercises 2F, you can pause the video and try to solve them all. And before you solve all the exercises, I have something that you can write down on a notebook. So for the quadratic equation, ax squared plus bx plus c, if you want to find out the symmetry of line, you can directly use the equation x equals b negative b over 2a. This is we call symmetry line equation. You can directly use it, okay? All right, so we'll stop here for 2.4 tutorial, and for the next tutorial we are going to go to 2.4 for the discriminant. Okay, hopefully you'll enjoy the video. See you next time.